Hi guys, I'm Rasul, and now in this video I want to talk about the meaning of Tally in MCNP and its usage. So at the first step, I will talk about tallies, different type of tallies in MCNP, and also I will talk about how we can use tally in MCNP. If we want to know that what is tally in MCNP, we must consider a function that help us to earn the parameter and quantity that we need. In every system, when we collect different things, different quantity to each other, we have a goal, and the goal is why we do that work. So in MCNP, when we create a geometry, when we create a materials, when we create source code and other parameters, we want to reach a goal. And the goal is the parameter that we want to earn. As an example, maybe we want to compute the dose. Maybe we want to compute current and other parameters. So in a short and simple definition, MCNP tally is a function that help us, and it's for earn or parameter. Before learning tallies, we must understand that just for specific parameters in a critically simulation, other tallies have normalized it. It means that when we calculate, as an example, a dose, it's not the real dose. It's a result that computed and normalized per source particle. So it's the important notice that we must remember. And also, beside of tallies, we have different cards, something like energy card, like time card, and other cards, that this card help us to earn more information or detailed information about tallies. If we will back about the tallies as an example, consider that we want that compute those in a specific area. The tally card just result one output, but if we want to earn roll of different energy, we can join tally card with energy card, that this card help us to compute our parameter. The standard tally in MCNP are 7 tallies that we can use, all of them with neutron, 6 of them with photons, and 4 tallies with electron. Here is a list of tallies and its usage. F1, we can use it for neutron, for photon, or electron, and F1 tallies is surface current. F2, that also we can use it with neutron, photon, and electron is a surface flux. There's difference between flux and current. In current, we have information about direction, and here in flux, we just have amount. Here we haven't any information about direction of the transport. F4 is a track length estimate or cell flux or volume flux. F5 have two different type, is a ring detector or point detector. We can use it in different type. F6 is a track length estimate of energy deposition of its energy deposition. Tallies F7 track length fission energy deposition is, we can use it just for neutron, is for critical source. And F8 is a pulse rate detector, is similar to the detector response in a real world. This standard tallies have quantities. F1 here is the particle. F2, the output unit is 1 over centimeter power 2 or centimeter square. F4 also. F5, F6 and F7 is a MeV per gram. And F8 is a pulse detector. Besides of this, we can use the tally with a star. It means that instead of using F1, we use a star. F1 is the energy multiplier, that when we use F1 tallies, the result is MeV, mega electron volts. F2 mega electron volts over a square of centimeters and others. And jerk is a type of energy unit that just used in MCNP. So the F1 or surface current is as we can see is the integral of current over position, over energy, over time, and over movement. Here is a momentum. So we can divide it. When we say that F1 is a parameter of energy, it means that we can use F1 in relation with energy cards. So here is the F1, and if we use a star F1, it means that here we use E product of J over this parameter. Similar F1, F2 card is flux. Here we can see that, let's change its position. Okay, I want to change the layout. If we compare these two parameters, or if we will back, if we compare F2 with F1, we can see that here the direction is not stored in F2 parameter. Here means the vector that consists of x direction, y direction, and z direction. Okay, consider a vector, a normalized vector. A normalized vector have three different parameters. y direction, z direction, x direction, y direction, and z direction. So here we can see the difference between Tally 1, and Tally 2. And here we can see that Tally 1 is calculated over the different direction. Let me copy it here to this slide. When we say that here is mu, we can use this tally with C1 with cosinus card that we will talk about it in the next slide. So F1 is the integral of J currency over the position, over the energy, over the time, and over the direction. But F2 is just integral of flux over the position, over the energy, and over the time. So the F2 tally can be joined with energy and time, but F1 can be joined with energy, time, and cosinus tally or cosinus card. The next parameter is F4 tallies. Then F4 tallies is the flux over the volume. Here is F4 tallies over the volume, and if we use a star F4, it means product of E and flux, that the result will change. The next parameter is, or the next tally is F5. F5 is the detector cards. We can use detector in two different conditions. The first one is as a point detector. It means that just a detector with a center and a radius. The next type of F1 is ring detector, something like this shape, Here we can change the inner and outer rings. So the next type is a detector, like a ring, that we must consider its center and also the radius from the center to the center of rings. And the last parameter is the radius of the ring. So tally type 1, 2, and other, and these tallies, here is also we have a slide about F1 tallies, detector tallies. You can see that here is a form of point detector. You can see that here is a form of point detector. In this situation, we must specify F5. Here is the position X, Y, Z, and also the rate. Here we have negative and plus sign. At the plus sign means that we enter the parameter with centimeter, and the negative is means that we consider the radius in the parameter of mean free pass. Here, mean free pass. Detector tally number type 2, we have the ring detector, F and A, and the Tally number, A, the letter. It means that we want to place detector over the X, Y, or Z. And also is a type of particles, distance along the z-axis A, where the ring place insert the axis. R is a radius, and here, similar to the previous, is R0 and is the ring of detectors. Now, the Tally type 7, 1, 2, 4, 6, and 7 is a general form and a simple form. In this simple form, we say Fn. After that, we define particle type. S1 to Sk is the parameter that we want to consider. What is the general form for this type? In general form, we specify Tally type, particle type, and here we can change the parameter here. As an example, when we say example 1, Fn here is 2, it means that we want to calculate Tally number 2 of particle of neutrons over the surface 1, surface 3, surface 6, and at the last we want to earn the total of this parameter. Here is another example, F1 of photon, and here we can say that 1, 2, it means that this surface, and also make summation of 3, 4, and 5, and at the next step talk about print Tally type 1 over the surface 6. Here is another example, F371. The last parameter, the last character in the Tally is the type of Tally. So it's also Tally type 1 of neutrons. At the first output, print current over surface 1 plus 2 plus 3 of another print output of Tally 1 over surface 1 plus surface 4, and the last output print the total. It seems that I must change this slide. And the Tally type 8, similar to the previous, is a simple form and general form like this. It's similar to the previous, and also we have S star is the energy position. Another parameter that we have plus F8 is the charge deposition. It means the charge deposition of Tally. The Tally related card is the cards, as we talked about that, the card that we can earn or we can learn more information about Tallies. The first one is energy card. Energy card for energy being, and we can divide Tally over the different energy. here is an example, E2, it connects to tally type 2 and it divides a result from 0 to 0.1 and other parameters. The tally, another related to the tally card is the time cards. Here are the time cards, and the time cards we can earn the result of tally over the time. Another parameter is angle card or is a CN or cosinus card, that the cosinus card help us to calculate tally over different direction. Another and last important card that related to the tally is EM or energy multiplier card, is a card that we can print result of output or product result with a specific card. Another card that's it's so useful, specific when we want to calculate current tally type 1 or 2 in different surface, is a FSN or Tallies segment. The Tallies segment help us to divide surface over the cards. Let's talk more about this card. Consider here is a table, but we want to use it with another specific, another goal. Let me to merge the cells, and also I want to consider this as a geometry. Okay? Imagine that it's geometry. And also consider that we want to find the flux or the current in different depths. Okay, different depths. We have two different methods for finding the result. The first method is that we divide the cells in subcells. It means that we need more time, and we must define different geometry because we must divide the cell into the different geometry, and also we find tally over subset. Another way to earn this goal is to use FSN. In this method, we define some surface card over this position, and with the FS card we use that. For example, here is F2 card, F2 tally of neutron over the surface 1, but change it FS2, we add FS2, it means that divide the result into surface minus. It means before surface 3, before surface 4, or before surface 3, surface 3, so over surface 3 and others. Or here is a F1 tally that we want to earn F1 of neutron over surface 1, surface 2 as a total. But by using FS1, we can divide it into different steps. So this course or this video was just theoretical, but in the next video I will talk about real example, and I will talk about how we can do this theoretical parameter or this theoretical information in real example. So have a good time until the next course.